Okay, here's our 8F part 2 notes. I want to talk just briefly about asymptotes. Again, I talked about them a little bit in the previous notes, but we ended up not really using them a lot. So, vertical asymptote is going to be whatever x value makes our denominator equal to 0. Okay? Because again, a vertical asymptote is going to make our denominator equal to 0. We can't solve for 0, and therefore we cannot cross that vertical asymptote because crossing that thing would make it equal to 0. Okay? Horizontal asymptotes. Remember, if the degree of the numerator is greater than the degree of the denominator, then there's no horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is going to be equal to y equals 0. If the numerator and denominator have the same degrees, then we'll divide the leading coefficients of the numerator and the denominator, a and b, respectively, and the horizontal asymptote will be at y is equal to a over b. Those are the rules on the notes. I want to apply these rules to where we go down to these 3 example problems right here. Hopefully this kind of helps us get a little bit more comfortable with these things, and then we can kind of we can go from there and try to identify asymptotes of these functions as we can go. So identifying the asymptotes vertical and horizontal. All right, I want to start doing the vertical of all 3. Okay, the vertical asymptotes of all 3. Now remember, the vertical asymptotes are where we set the denominator equal to 0. Okay, so the vertical asymptote here would be where x squared minus 1 equals 0. For this one, it would be where x squared minus 2x minus 15 equals 0. Okay, and this one is going to be where 3x squared plus x equals 0. Okay. So on this one here, the first one here, we could factor, or we could just get x by itself. So either way, we could work because it's a difference of squares. We could also factor it. So if we x squared and we add 1 to both sides, so we could have x squared equals 1. And so to get x by itself, we square root and square root. So x could be positive or negative 1 because the square root of 1 is 1. Okay. So the vertical asymptotes on this one, okay, would be x is equal to positive or negative 1. Okay. Second one, we have x squared minus 2x minus 15 equals 0. Got to factor that out. Okay, so we factor it out by doing our regular trinomial factors right here to set equal to 0. So 2 numbers that multiply to negative 15 that add to negative 2, which should be negative 5 and 3. Negative 5 times 3 is negative 15. Negative 5 plus 3 is 2. And we set both of these things equal to 0. Okay, so that would mean x equals 5 or x equals negative 3. Okay, because we got to set both those parentheses equal to 0. So these would be the vertical asymptotes of this graph. All right. And then over here on this last one, 3x squared plus x equals 0. So we'll just have to factor this out. So we can pull an x out here and we get 3x plus 1 equals 0 there. Okay. So in this one, we can make the x equal to 0. Or we can make 3x plus 1 equal to 0, where x would be negative 1/3. The horizontal asymptotes are going to be a little bit easier to do because all we have to do is look at the degrees of these things here. So in this first one here, the numerator has a degree of 0, okay, because there's no x up there. The denominator has a degree of 2, okay, because the x has a second power. So the n is less than the m, which means the horizontal asymptote is going to be at y equals 0. Okay, because the n is less than the m. Okay, for here, the second one, the horizontal asymptote, well, here, the n, the degree of the numerator is 2 because we have x squared, and the degree of the denominator is 2 because we have x squared there, so n is equal to m. Okay, so now we have to divide the leading coefficients. Okay, so the leading coefficient up here of x squared is 1, because 1x squared, and the leading coefficient of x squared down there is 1. Okay, so the horizontal asymptote here is going to be y is equal to 1 over 1, which is 1. So the horizontal asymptote for that second one is going to be at y equals 1. And we're going to graph these up here in a minute just to sort of check our work. Okay. On this last one, here we have the degree of the numerator is 3. The degree of the denominator is 2. So n is greater than m. Okay. The degree of the numerator being greater than the degree of the denominator tells us there's going to be no horizontal asymptote. It ain't going to exist. So let's go over to Desmos and check our work. So we have, y equals x squared minus 5x. What is it? Y equals 5 over x squared minus 1. So y equals 5 over x squared minus 1. So we have this graph right here. And so they tell us that the vertical asymptote was going to be at x equals positive or negative 1. Okay, which sort of looks like it is here because here's positive 1 and negative 1, and so it's going to touch it and never really come close. So here's our vertical asymptotes. Whoops. Vertical asymptote here, 1 and negative 1. All right, and the horizontal asymptote is going to be at y equals 0, which it does. Okay, the graph infinitely approaches 0, but it never touches it. Let me clear the screen here. Okay, so it's going to infinitely approach 0 but never touch. So horizontal asymptote of y equals 0, vertical asymptotes of positive and negative 1. Perfect. And the next one, x squared plus 9, x squared minus 2x minus 15. So y equals x squared plus 9 divided by x squared minus 2x minus 15. Okay, so our vertical asymptotes, we said we're at positive 5, negative 3. All right, positive 5, negative 3. So x value of positive 5 right there. Looks good. X value of negative 3 right there is good. We have these two asymptotes. We see the graph is never going to cross these two things right there because that would make our denominator divide by 0. And the horizontal asymptote we said was x equals, or y equals 1. Excuse me, y equals 1. Okay, so at y equals 1, that's our horizontal asymptote right here. And that's perfect because our graph never crosses that horizontal asymptote right there. Okay, so that kind of checks itself out. Okay, on the last one, we got x cubed plus 27 over 3x squared plus x. Here's our graph. Okay. So vertical asymptotes, we had negative 1/3 and 1, I believe. No, x equals 0. Sorry, x equals 0 and x equals negative 1/3. Okay. So x equals 0 is one asymptote. So the y-axis is one asymptote. And then x equals negative 1/3, which is probably somewhere right around there. This graph goes up really high, so it's kind of hard to see, but for all intents and purposes, it looks like that's what we got. We're not going to touch the y-axis, so we're not going to pass y equals negative 1/3. And then horizontal asymptote, it said we weren't going to have one. And it looks like we don't, because we don't have any horizontal line that we approach. All right, so that's some good proof right there where we can kind of see our asymptotes in action and apply our rules. And so now you guys can go ahead and do these and then use the Desmos calculator to check your work. If you have any questions, let me know and I'll be happy to help you out. You take care.